Consider the sequences given in the table below. Find the least number n such that the nth term of the geometric sequence is greater than the corresponding term in the arithmetic sequence. So, if you look here right now, in the arithmetic sequence and geometric sequence, for the first term, the arithmetic sequence is greater than the geometric sequence. For the second term, we can see that the arithmetic sequence, which is 4,000, is greater than 16. For the third term, 7,000 is greater than 64. For the fourth term, 10,000 is greater than 256. For the fifth, again, 13,000 is greater than 1,024. For the sixth term, we have 16,000, and that's greater than the 4,096. So what we want to do is we want to continue and then find out, okay, what is the seventh term, and so on, and then we want to compare those. So all I'm doing is just adding here, looking at term number 7, and let's see what we get. Okay, so the first thing we want to do is, for the arithmetic sequence, we know that the first term is 1,000, we know the common difference is 3,000, and we know that the seventh term is what we're looking for. So we're going to use our arithmetic sequence formula. So we're looking for the seventh term, a subscript 7, where the first term is 1,000, plus n, which is 7 minus 1 times 3,000. Well, 7 minus 1 is 6, and 6 times 3,000 is going to give us 18,000 plus 1,000, and therefore the seventh term of the arithmetic sequence is going to be 19,000. Okay, now let's take a look at the geometric sequence in the seventh term. So for the geometric sequence, we see that the first term is 4. We know that the common ratio when 16 divided by 4 is 4, and we're looking for the seventh term. So we want to look at the following formula for the geometric sequence. So we're looking for the seventh term, where the first term is 4, the common difference is 4, and we're raising it to the power of n minus 1, which is 7 minus 1. Well, 7 minus 1 gives us 6. So this is 4 to the 6th power, and then this is 4 to the first power. Now remember that when you multiply the numbers of the same base, you add your exponents. So therefore, we get a to the 7, which is 4 to the 7th power, and 4 to the 7th power is 16,384. So we can see here that 19,000 is still greater than the next term. So in the seventh term, the arithmetic sequence is still greater than the geometric sequence. Now let's try the eighth term. So here, we're going to try the eighth term. Okay, let's move this up here a little bit, just get a little more room. Okay, so we want to find the eighth term. Again, we know the first term is 1,000. We know that the common difference is 3,000. Now we're going to plug in n is equal to 8. So we have 1,000 plus 8 minus 1, which is 3 times 3,000. And so 8 minus 1 is 7. 7 times 3,000 is 21,000. And 21,000 plus 1,000 is 22,000. So we're going to get 22,000 for the arithmetic sequence for the eighth term. Now let's take a look at the geometric sequence with the eighth term. So what we're doing is, again, we're using the first term is 4, their common ratio is 4, and the eighth term, so n is equal to 8. So plugging that in for the seventh term is 4 times 4 to the 8 minus 1. Well, 8 minus 1 gives us 7. And remember, when you multiply with the same base, you add your exponents. So therefore, this becomes 4 to the 8th power. And 4 to the 8th power is 65,536. So 65,536. So what do we notice? We notice that in the eighth term, you can see that now the geometric term is going to be greater than the arithmetic term. And that's what we wanted to find. So therefore, we would say the following. We would say that since 65,536 is greater than the 22,000, the geometric sequence overtakes the arithmetic sequence at the eighth term.